Hi guys, I know you're planning to pursue a master's through the Futurense US pathway at Drexel University. I know you have a lot of questions about what really happens in that university, how does the curriculum work, how are the professors, how is the campus life, and most important, what about placements, what is the placement track record of that university. Well, I have been talking to the experts, the people who are representing that university in varied forums to try and understand what does it mean for you, how does your life look like when you study in that university, what happens during your study and post once you complete your masters, what about the job prospects. If you're interested to know about these things, definitely watch the full video where these guys are talking about from their viewpoint why is this an exciting opportunity for you, and I am asking them questions that you guys have emailed it to us about specific nuances about how can you pursue your masters from your dream university, how can you land admission there, and what happens to you post you finish your masters in your dream US university.
Hello, everyone, and welcome to this wonderful webinar. So we have with us the fantastic team from Drexel, who are led by Dr. Kapil over here. And today we'll be getting some insights into this interesting US Pathway program that we have in collaboration with Drexel University, and what are the highlights and features of this particular program. So over to you, Dr. Kapil.
Sounds great. So thank you all very much for your interest in the College of Engineering at Drexel, and we're very happy to be working on this partnership with you all to recruit students to our program. Yeah, so my name is Kapil Dandekar. I'm the Associate Dean for Enrollment Management and Grad Education in the College of Engineering, also Professor of Electrical and Computer Engineering. I've been at Drexel for about 22 years, and very glad to have a chance to tell you about our programs. I'm very happy to be joined on this call by a number of my faculty and staff colleagues on the Drexel team. And if they could type their names and departments in the chat window, so our visitors know who are here, we'd be very happy to answer questions that you might have about the partnership. So this is what we'll be discussing. We'll provide an overview of Drexel University as a whole and talk about graduate programs in the College of Engineering in particular. I'll lay out some of the basic aspects of the partnership between Drexel and Futurense, to create pathways to our master's programs in engineering. To give you a general sense of some of the faculty expertise and research capabilities, as well as some of the material that's available in teaching laboratories, I'm going to describe several research projects that are going on in the College of Engineering to give you a good idea of some of the great work that's happening here. We'll talk about career development resources that are available. This could be used not only for a full-time job search, but also in support of cooperative education, which is something that Drexel is known for, that allows up to 6 months of practical work experience to be integrated within the degree. We'll discuss the various degree options that are available through the partnership, discuss the idea behind the degrees, as well as provide a description of some of the exciting courses that are in each one of the programs. And discuss student and alumni outcomes, and then conclude with a discussion of the application process. So again, very happy to have a chance to tell you about our programs. So this is a picture of our urban campus located in the heart of Philadelphia. You can see Drexel University in the foreground. The College of Engineering is located in the cluster of buildings that are shown very prominently there in the foreground. You can see the skyline of Center City, Philadelphia in the background. Philadelphia really is a nice place to live, work, and study. It is a cultural center that's welcoming to populations from all over the world. Drexel is also known for being an R1 research-intensive university. This is the highest level of research activity. What this means for you as students is that our faculty are leaders in their respective disciplines. You'd have access to top-notch facilities that you wouldn't have access to at other institutions. So this is something that we're quite proud of, because there are very few urban private R1 institutions, and Drexel's very happy to be on that list. As I mentioned, Drexel is also known for our history of cooperative education. For our master's programs, this allows up to 6 months of practical work experience to be integrated within the degree under a CPT. We'll discuss that later on in the presentation. And then while Drexel is a comprehensive university, if you look at the history of Drexel, it really is centered around engineering, as engineering is the flagship college. I mentioned that Drexel is located in Philadelphia. It's located on the east coast of the United States, between New York City and Washington, D.C. Our campus is 1 block away from 30th Street train station, which is a major transportation hub in the northeast of the U.S., so it's very easy to hop on a train and be in New York City or Washington, D.C. in a couple of hours, as well as get subway, bus, and trolley connectivity to other parts of the city. Philadelphia is one of the most walkable cities in the United States, according to several rankings organizations. And you really don't need to have a car to get around our campus. We're close enough to the airport. You can take public transportation in terms of groceries and living and other things like this. You really don't need to have a car to get around our campus. Philadelphia is also considered to be one of the best student cities in the United States, given the innovations that we have in Philadelphia, the number of universities that are clustered, as well as all of the art and cultural and other opportunities within Philadelphia. If you're into great restaurants, Philadelphia has a nice scene, as well as great museums and other opportunities. And of course, if you want to get access to more rural parts, another block away from our campus is Schuylkill River Trail, which will lead to one of the largest in-city parks in the United States. So again, a very nice place to live, work, and study. Drexel University is on the quarter system. Unlike other universities that have 16-week semesters, we have 4 10-week quarters where each one aligns with one of the seasons. The typical start for most of our programs is in the fall quarter. Although winter is possible, but typically we try to send as many students as possible to fall. The classes there start in late September, September 23rd, 2024 is when they would start. And while international students can apply till June 1st, through partnership programs such as this, we really encourage you to apply as soon as possible. So this partnership we're very excited about. It has academic pathways to a number of our degree programs that are listed on the slide, and I'll go through in detail later on. So you can see pathways in machine learning engineering, Internet of Things, computer engineering, robotics and autonomous systems, cybersecurity. Realized a typo on the slide. We also have a pathway to engineering management, which I'll also describe later in the presentation. The MS cybersecurity is available as well, although for that program, we can offer pathways through the engineering track of the program, geared towards people with an engineering and computing background. If you're coming from more of a information systems or information technology background, that degree probably wouldn't be a good fit for you. We allow up to 15 transfer credits, quarter credits as transfer, and this transfer paperwork needs to be submitted as part of the application process. So we'll discuss that more a bit later. Our Drexel MS programs are typically 45 quarter credits, but with the accepted transfer credits through the partnership, the program would only require 30 quarter credits for a degree completion. We've negotiated a good discount, I believe, for students to participate in the program. So there's a tuition discount that's available for the credits that you would be taking at Drexel. And there are pathways available through the program that include and don't include graduate cooperative education. And we'll talk about the timeline for these later on in the presentation. As I said, research is at the heart of the College of Engineering. We're an R1 intensive university. We have over 100 faculty involved in research, and our discovery and commercialization infrastructure is quite active. To list some research projects affiliated with some of the programs under our partnership and just give you a representative list of some interesting research that's happening at Drexel. This is also reflected in the coursework that will be available through the partnership. So the first area that I'll discuss deals with multimedia forensics. We have a multimedia and information security lab led by one of our faculty members that essentially uses machine learning to detect whether or not images or videos have been manipulated. The top 3 figures on this slide show a picture that's been doctored to indicate that a student with a Vans t-shirt is looking at a vast set of cars, but then there's an original image that's clearly then been doctored in order to convey some message that was not originally present. And this is particularly important since we live in a world where people are concerned about fake news, about images or videos that might be manipulated to contain messages they don't contain. So you can use machine learning approaches to analyze the images and tell where and how they've been doctored. The pictures on the bottom of the slide show pictures of synthetically generated people. The person in the middle of the slide is not a real person. It was actually generated by an AI generator available online. And the laboratory is developing techniques to develop fingerprints associated with these fake person image generators and develop classification techniques to tell not only that they're fake, but also what tools were used to create them. And this, again, is particularly important as people are wondering about the authenticity of information that's being shared online. We also have a great robotics laboratory that's affiliated with a number of our classes dealing with robotics and autonomous systems. This is a lab that's run by Professor Lifeng Zhao. He runs an experimental laboratory. You can see some of the robots that are in his laboratory. You have robots that are on the bottom left movie. You can see drones that are being risk aware, tracking the drones that are on the that are on the ground. The drones on the ground just kind of go through the center, but the circle area there is something that's kind of deemed to be off limits or dangerous to them. So the robots have to figure out how to steer themselves. Multi-robot tracking, you can see micro drones dealing with ground-based robots and developing path planning and tree sensing technologies. And this is some really exciting research that we have going on at Drexel, one of the leaders in the field in the area, in a number of areas. And it's available as well as part of laboratory-based coursework that's as a part of the degree. We also have some classes, and I'm particularly biased by this one since this is my class, but this is a course that we offer in software-defined radio. So this is part of a number of our degree programs where students can use real radio equipment to transmit information and see how that information can be transmitted in the presence of hostile jamming. So students can take this course, learn how to create and transmit and receive real analog and digital communication signals, learn how they are resilient in the face of jamming. The class also includes what we call a radio wars project, where the students have to transmit information to either race their radios to see who can transmit the most data, or have their radios operate in the presence of a jammer. And that's actually what's shown in the waterfall picture on the top right, data being transmitted with a jammer that's trying to prevent the transmission. And this is actually real student work from last term or last year, where the students were trying to adapt their radios in a particular way. You can also see some pictures of the radio facilities that are at the bottom of the slide, showing students who are prototyping new types of radar technologies in the lab. So again, you get access to facilities and expertise that you wouldn't have access to at other institutions. So let's talk now about graduate cooperative education. Graduate co-op provides an opportunity to get practical work experience as part of the degree. In the fall quarter, students would enroll in a co-op 500 level class to learn about our Steinbrück Career Development Center and all of the resources that it offers. Unlike other universities where you might be walking across the stage of graduation and thinking about meeting someone in the career services office, at Drexel, you'll start that process right when you become a student. So they'll teach you about alumni resources, career fairs, employer databases that are available to help you with both a co-op and full-time job search. They'll also help you review your resume, review your LinkedIn profile, articulate your career goals and interests, and just conduct yourself in a professional workplace environment. For those students who participate in co-op and get employment, these are typically paid experiences with an average salary of $1,000 per week for an up to 6-month experience. So this allows you to start earning money, which can offset the cost of education, as well as gain professional experience as an engineer. And there are no additional tuition costs when you're a co-op student for the co-op quarters. This is the list of some of our sample graduate co-op employers. You can see a mix of different types of technology companies in a diverse set of areas. Our students find jobs in many different areas and do quite well for themselves, not just in co-op employment, but also in full-time employment. This is a survey of one of our recent students who's on a graduate co-op, who's one of our student ambassadors. And you can see that he's done some really great work and had some good experiences working at a startup, working on new types of ultra supercapacitor technologies. We get a lot of great experience by working through this program. This is what our program timeline looks like, both with and without cooperative education, assuming 15 credits of transfer credit that have been accepted. Students, if they choose not to do a co-op, can complete the program in as little as 9 months with 30 credits. With a co-op, they can do fall, winter, spring at 9 quarter credits in fall and winter. 9 credits is considered to be full-time employment. Full-time enrollment for visa purposes. You'll do fall, winter at 9 credits. Do a vacation quarter in the summer and then do a fall winter co-op. I do have 2 spring quarters shown there at 12 credits each. That is a bit of an overload, but students can choose to spread that out, take a less than full-time term if they don't want to overload, or take one of the 3 of those credits while they're on co-op. So there is some flexibility there that you can work with your academic advisor to find a plan that works best for you. So this is a list of our various MS programs that are part of the partnership. And again, I've had a typo on my previous slide. So I have engineering management that's listed here, as well as the other programs in computer engineering, cybersecurity, Internet of Things, machine learning, and robotics. I have a series of slides on this, and I'll ask my Drexel colleagues, Professor Kandasamy and Professor Grandrino, who are here to chime in when I get to their respective programs. But the first one that I'll discuss is the MS in computer engineering. And actually, maybe Professor Kandasamy, if you'd like to say a few words about this, please feel free.
Thanks, Kapil. Welcome, everyone. My name is Naga Kandasamy. I'm a professor in ECE, also the department head for ECE, actually in the computer engineering area. We have a fairly robust program in computer engineering, and I'll just point out a few notable courses here. So essentially, we're operating close to, if you think of it as a software stack, we are operating close to the hardware. If you're a computer engineer, essentially on the boundary between hardware and software, so that at that interface layer. So we offer a number of classes. So if you look at it from the bottom up, our most popular classes are these 571, 572 that I've listed here. These are essentially chip design classes, and chip design is now becoming a big deal, at least in the United States, with the manufacturing moving back, or at least as an attempt to move back semiconductor manufacturing back to the States. So that's your chip design. At the interface layer, we are looking at the compiler design. So how do you take a high-level program and compile it down to machine code that will run on those chips? 621, it's a fairly popular course as well. That's basically what we call microarchitecture design. So how is a processor put together? What sort of features do you need for a processor to run fast, also consume less power, and so on and so forth. And then 622 is, I don't know how many of you play video games, but these video games have what we call video cards, and NVIDIA used to be a very big player in it. Now they're a big player in what we call high-performance computing. And these are chips that are massively multi-core. So these are chips that are thousands of cores on a single piece of wafer. So think of them, each core as a computing element, right? So you have about 10,000 plus cores on the single piece of wafer. And then the question becomes, can you program these, right? So can you take a program and can you parallelize the program in a way that can use all of those 10,000 plus cores on that piece of wafer? And this is now a very popular type of thing to do in industry, because everything any large scale system like weather prediction, simulations, they're all run in parallel, right? So it's a very good skill to have. So to summarize, this is like a full stack. So from the bottom up, chip design at the interface layer, which is be your compilers, and then at the slightly above that layer would be how do you program these platforms, for example. Next slide, please. So we also offer a MS in cybersecurity. Now, as Kapil pointed out, the track that we will be offering is what we would call the ECE track, which requires engineering background, like computer engineering background. So we have a diverse set of classes in cybersecurity. You can see some of those classes there. We have web security classes. So how do you make a website secure? How do you on the back end, right? How do you build software that is secure? 620 is multimedia forensics and security. Kapil already pointed out a good example. If given a image, can you tell us whether it's doctored or not, right? Has somebody copied and pasted additional material into that image? Has somebody deleted stuff from the image? Given videos, has somebody deleted frames from the video, inserted frames into the video? So on and so forth. So here there is some overlap with machine learning because the most recent techniques, state-of-the-art techniques in multimedia forensics and security use machine learning to detect what we call image and video forgeries and falsifications. Right. We also have classic dependable computing. So this is what you would think of as fault-tolerant systems. So if we are in a car or a plane, a single failure or multiple computer failures should not bring down the entire system. So there's a well-defined area called fault-tolerant embedded computing. How do you continue the system functionality, right, in the face of hardware and software failures? So we have classes in those. And then 576 is an interesting class. So if you have a design, and if you send it off to a chip company to tape out the design and the hardware comes back to you, there's an increasing interest in to detect if somebody has messed with your design. In other words, introduce something what we call a hardware Trojan in your chip. Right. So the Trojan could be sending information back to some other entity that you are not aware of. So there's a big field of a very recent field of work that looks into how do you make hardware systems like chips secure, again, in the face of malicious circuits being introduced in the hardware and other things of that nature. So we offer a set of classes. We are also now in the process of creating new classes that merge machine learning with cybersecurity. Because machine learning permeates every field that includes cybersecurity as well. So machine learning is what's typically used now to detect if a file contains a virus. In the past, people used to do signature-based analysis. Now it's mostly machine learning. Also high performance of large-scale computing systems. You would collect data, which is in the form of time series, right? Like CPU utilization, memory utilization, so on and so forth. And you can train these machine learning models to analyze time series data to detect anomalies in them. So we are currently in the process of creating a few classes that kind of marry machine learning along with applications to cybersecurity. Right. Next slide, please.
Yeah. So I'll hand it over now to Professor Rick Grandrino to discuss some of the exciting courses that are and the program associated with engineering management.
Thank you, Kapil. Hi, everyone. Pleasure seeing all of you today. I'm the Director of Engineering Management and Systems Engineering Program. First, I'm going to talk about our Engineering Management Program. It's a nationally ranked program. We're ranked one of the top 10 in the U.S. according to U.S. News and World Report. It's an excellent program where it's taught by experienced professionals. Now, what I mean by that is all of our faculty members have significant experience in industry, working at various levels of management and management and technical organizations. And we often describe that our engineering management program is different from an MBA in that it's focused towards technology and managing in technical organizations, which is a bit different than what the MBA teaches you, because the MBA gives you a general roundabout knowledge of industries that aren't so technical, and this is one of the strengths that we really encourage anyone that wants to stay technical. Like I myself, I worked 32 years at Lockheed Martin. I was both a systems engineer and various levels of management in engineering throughout my career. And it's a bit different when you're managing technologies, especially research and development. So we focus on teaching leadership skills and providing you skills to manage both capital and human resources within technological organizations. We're also certified by American Society for Engineering Managers, and you see their icon right here in this slide. And this is a tribute that we're well connected with industry, and this is one of the ways that we're connected with industry. The American Society for Engineering Managers is a guideline. It has the guideline for the Society of Management related to technology and engineering, and we're connected with them to a point where they actually certified our program. So what that means is upon graduation, not only do you get a master's degree, master of science degree in engineering management, but you'll also get a certificate from the American Society for Engineering Managers. And ordinarily, to get this certificate, it would take you about a year or so. You got to study their handbook, take a couple courses, and then take an exam and pass the exam. Just by going through our program and completing our courses, you automatically qualify for certification by American Society for Engineering Management. We also have some certificate programs, and sometimes students don't want to commit to a full program. And in a lot of cases, our students start off with certificate programs. We have two of them here, the Engineering Management Certificate and the Engineering Technical Leadership Certificate. The Engineering Management Certificate is a subset of the core courses in our program, the Engineering Management program. So those courses that you complete, it gives you a good fundamental of the knowledge you need and leadership skills for engineering managers. Doesn't quite go into depth as much as the master's degree, but it gives you a very good foundation for management in technological organizations. Now, the engineering technical leadership is kind of a combination of both our systems engineering and our engineering management programs. Both certificate courses are transferable. So the courses that you take, if you want to continue on for the master's degree, you can do so. And these courses that you take will apply towards the master's. To complete the master's, you need complete 15 courses or 45 credits. And we're on a quarter-semester system. So we have quarter-semesters rather than semesters. And they're about 11 weeks, and they correspond to the seasons, just as Kapil had said, fall, winter, spring, and summer. We're finishing the fall term right now, and we're going to be starting the winter term January 8th. And so you take 15 courses, they're 3 credits each, it's 45 credits, and that's equivalent to a 30-credit curriculum if you're taking a semester-based program. But you take 10 core courses and 5 electives, and you could tailor the electives to any field of interest. For instance, you heard about the cybersecurity. If you're interested in cybersecurity, you could take 5 courses into cybersecurity to go along with your degree, and that would count as your electives. So we're very versatile in that perspective, that you take 10 courses, you take 5 courses of electives, and tailor the electives to your field of interest. Is there another slide here, Kapil? Next slide.
Oh, no, there isn't. Yeah, thanks, Frank. I appreciate it. No,
Okay,
that's
thank you.
Thank you. Yeah, so we also have a MS in Internet of Things. That's part of the partnership. So the future that's envisioned by the Internet of Things envisions having essentially all of our everyday devices all around us connected to the internet. That comes with it a lot of challenges. There are many different applications that are available, including like health monitoring, sensing, within buildings, outdoor sensing, developing smart mobility solutions, developing new environmental technologies, and fusing data together from different sensors to enable exciting new applications. So what's really great about our IoT program is that it allows you to take pathways through the program, looking at different aspects of the wireless networks that build up the Internet of Things. You could look at courses in radio frequency electronics if you're interested in how these devices transmit information over using electromagnetic waves. You can look at the embedded system aspect of this, looking at how you make integrated circuits that are specific to IoT devices. And I think what's really exciting about our program is that it offers hands-on laboratory-based courses. So I described the software-defined radio laboratory class that I teach, where the students will transmit information that's used and are similar to the types of signals that are transmitted in IoT systems. We have a hands-on computer networks class, which is also a great class where the students can use real radio or real wired network technology to learn how telecommunication networks are realized. There's a class that I teach that's called wireless systems, where the students will learn essentially about some of the propagation aspects of signals and different standards that are involved in cellular and IoT related standards. And then an internet laboratory class, again, where students can get great experience using different types of devices to transmit information. So great combination that allows you to customize the pathway through different fields, depending upon your area of interest, as well as an opportunity for some hands-on coursework. So I don't know, Professor Kandasamy, if you'd like to say anything more about that.
No, just to point out that these are just so these, if you look at these classes, they're that we have on there, they're essentially focused on that one area of computer networks, more or less. But we have a number of classes on our wireless systems. We have a number of classes if you wanted to do embedded systems programming, right? FPGA design and programming, digital systems, and also, as Kapil said, we have a very strong, robust program in RF engineering, radio frequency electronics, antenna design. So it depends on your specific interests as it relates to the Internet of Things. So you can chart your own path through this particular program. Thanks, Kapil.
And do you want to take the next one, next two?
Sure. So this is the MS in Machine Learning Engineering, also quite popular among our students. So the way the program is structured, I mean, as I said, machine learning permeates almost everything, every aspect of electrical computer engineering these days. And you will see this in our programs as well. As I said, cybersecurity, we're working on classes that use machine learning in order to do anomaly detection. If you take computer engineering, for example, and I'll bring that up soon. So if you take computer engineering, we have classes that talk about hardware implementation of artificial intelligence and machine learning. That's because for all of these, most of you are now familiar with ChatGPT, large language models. These machine learning models are now extremely large with billions of hyperparameters. And to train these machine learning models now consumes a lot of energy. And the corresponding carbon emission is as large as a country like Argentina. So there have been studies that now talk about the climate impact of training these machine learning models and using them. So there is a lot of interest now in developing hardware that are specifically intended. They're not general purpose hardware, but these is hardware chips that are specifically intended to what we call accelerate machine learning workloads. And you can see ECE 613 there is a new technique, like a computing technique called neuromorphic computing, where there is a effort to figure out how our brain processes information. Our brain does not process information the way typical machine learning algorithms run, right? They simply are trying to emulate them, learning by example. But neuromorphic computing actually physically, from a structural point of view of the hardware itself, tries to emulate how our brain processes information, because our brain processes tons of information in a very, very energy efficient fashion. Right? Our brain doesn't overheat and blow up, given the amount of information that it processes. And there's a lot of work in this area. And The hope is that these types of new computing paradigms will drastically reduce the amount of energy consumption that's currently being incurred on training these machine learning models, right? So we have some of these kind of very cutting edge classes as well. But fundamentally, the program is organized in machine learning fundamentals. So in this, you would say 610 is a fundamental class, machine learning, artificial intelligence. I think most of you are taking it as part of the IIT program as well. We have pattern recognition. And then we have implementation of machine learning algorithms. So we have a fairly popular class called ECE 612, which is applied machine learning, basically very little mathematical background needed. The idea is to just teach the students how to, use TensorFlow, Keras models, loading data sets, cleaning up data sets, training the model, and deploying the model, running inference on it, right? The basic stuff. And then we have a number of classes that deal with the applications of machine learning, which some of it is the multimedia forensics. Computer vision is an obvious answer, right? Image processing. We have bioinformatics. We have very specific classes, like if you're interested in the health sciences, people are using machine learning for cell imaging, tissue imaging. So we have a number of such classes. So you learn the fundamentals. You will learn how to implement these things in industry standard software, and then how to apply the concepts in these applications. And if you have a computer engineering background, which means a hardware background, we also recommend that our students kind of take VLSI design and ASIC design. Because that's where computer engineering chip manufacturers are going as well. In other words, designing hardware to accelerate the machine learning workload. Right? Thank you, Bill. And finally, I believe this is the last program, which is the MS in Robotics and Autonomy. Also very popular at this point. There's a lot of interest in robotic applications in business and manufacturing, and it's rapidly evolving, changing. So robotics involves two major components. So it's a multidisciplinary topic, right? Locomotion, how do you make the robot move, navigate, right? So locomotion is a control theory problem. So you're modeling the dynamics of the robot, and you have control loops that will actuate, right, the plan. The other portion of robotics is what I call cognition, a perception. Was how does a robot perceive its environment? How do you do object detection, right? So if you want to go from path A to path B, how do you path plan? What happens if you meet obstacles in the middle or during the path? So how do you detect objects? How do you navigate around objects? So that would be what we would consider perception. And at this point, there's a lot of computer vision, a lot of machine learning topics at that level. And the locomotion level is control theory, right? So we have a mix of classes. Some of the notable classes, we have created a number of new classes in that area. ECET 580, which is a class on mobile sensing and motion planning. Like what I said, it's path planning, multi-robots, right? ECE 608 is decision making for robotics, because these are onboard computing on the robot. So they are power limited, they may be compute limited. So you cannot, so decision making with those constraints is an interesting problem. One of our more popular classes is computing and control. So those of you who have taken control theory in a theoretical fashion, you deal with it in continuous time, right? You have a transfer function, you have input output, and you say, cool, I'm done. But then, of course, the next question is, could you put it on a microcontroller? Could you take your control loop law and implement on a microcontroller? Now that is a tricky problem. At that point, you're operating in discrete time. You're operating on a very low power device. You're no longer going to get, something like a 32-bit floating point, maybe not even a floating point multiplication unit. So these are all the constraints that you come into play when you're actually implementing a control loop that you have learned in theory in practice on a microcontroller. And that is a class we have called Computing and Control, which is 603. which is also a very interesting and popular class. And finally, the reading off the list here, we have medical robotics is a big deal. So there's a lot of interest in remote surgery, and there's a lot of companies working on these robots to help out surgeons, right? And it's a field called medical robotics. So we offer a couple of classes in medical robotics, which is 561. So overall, it's a interesting, very good, well set up program dealing with various aspects of robotics, both on the control side as well as on the cognition perception side as well. Thanks, Kapil.
Thank
I
you.
think that's right.
Yeah, so as I mentioned at the beginning, our Steinberg Career Development Center is available to help you with a co-op and full-time job search. These are the various services they'll provide. They'll help you prepare for an interview, review your resume and LinkedIn profile. They'll teach you networking strategies, job search skills, and how to negotiate a salary. There are also various resources that are available, alumni networks, career fairs, employer databases that'll be available to help you with full-time and co-op job search. Speaking a bit about some of the outcomes of our students, the vast majority of them are employed or are going further in graduate school. For those who participate in the grad co-op program, an appreciable number of them end up getting a job with a former co-op employer. The vast majority of students are satisfied with the jobs that they get. And we see starting salaries at the average level being $88,000, with some majors reporting over $100,000 at graduation. So our graduates do very well for themselves and are satisfied when they come through our program. To talk a bit about the application process, go through the components of the application to Drexel. We have a number of members of our college recruitment team as well here as well, Sherry Levin and Cookie Ma, who can help with answering questions. But a completed application, we're generally looking for students who have a BS degree in engineering or an engineering related discipline from an ABET institution or equivalent institution overseas. We are generally looking for undergraduate GPAs of 3.0 on a US 4.0 scale. While you can apply to our programs with unofficial transcripts, you will eventually need official transcripts from all undergraduate institutions attended in order to enroll in classes in our program. We will also need the application for graduate transfer credits as part of any certificates that you take as part of the Futurense program. There'll be 2 letters of recommendation. It can be from a former undergraduate advisor or a teacher, or someone in a supervisory role at work, a resume. We are test optional, so no GRE test that's required. There's no standardized English test that's required, assuming that English was the language of instruction when you were going to school. There's a 500 to 750 word essay that's part of the application, where you can discuss your background and interests. And again, it's important that we have that credit transfer form that we'll provide and should be included as part of the application. Once accepted, the students will be notified electronically, and a formal letter will be mailed to the students. You can see the tuition costs. As I mentioned, we have a partner discount that's negotiated with Futurense that will be reflected in the Discover Drexel portal. You'll be asked to confirm your enrollment in the program after being notified. If the students need more time, they can request an extension. To have the I-20 generated, you'll need to pay a $300 deposit. This deposit can be applied towards your tuition, but that's what's needed for confirmation to have the I-20 process begin. And then that will begin after you confirm your enrollment. There are a number of us who are here to help you with the application process. Our names and email addresses are here. But now I think we're want to thank you all for your attention and open it up to any questions that you might have.
Thank you, Dr. Kapil. That was a really wonderful explanation and walkthrough of what Drexel has to offer for our candidates. Now, some of our candidates have some few general queries. I would like to start by one centered around the mentorship network that Drexel has and how it leverages its industry connects, its network of alumni to better facilitate our candidates once they're in there?
Sure. Yeah. So we have a number of resources that are available. So we have career fairs on campus. Our Steinbrück Career Development Center has between 1,600 and 1,700 different employers in our database, and these are companies that are located not just in Philadelphia, but all over the country, and in fact, all over the world. So there's a rich network of companies that maintain relationships with Drexel and for both the cooperative education and full-time employment. The students do very well for themselves when they go through the program, so students use different resources to find jobs. They can go to career fairs. They can get a co-op. They can talk with alumni. Use the employer database. So many tools that are available.
And you did mention that they will be getting help regarding curating their CVs, their LinkedIn profiles, and all of that as well, both in co-op or in full-time job search. So are there any special initiatives or programs that will bridge the gap between these master students and industry professionals?
So you mean as part of the curriculum?
Yeah,
well,
or in general.
So the Steinbrück Center does do a lot of kind of mapping with industrial professionals. So there are alumni resources that are available. The departments also do manage seminar series where speakers from external organizations will come in and can describe some of the cutting edge work that's happening. We have employers who also come to our campus and will recruit our students. Philadelphia is increasingly a hub for innovation, so we have some major companies that are building facilities in and around Philadelphia so that they can access the talent pool that's coming out of the university. So, there's that. There are also student organizations that students can get involved with, professional societies associated with various engineering disciplines that provide students to start building their professional network with people from industry and academia.
So outside of academia, do you have any highlight clubs that our candidates can get to know about so that they get to develop their co-curriculars as well parallelly?
Sure. So I might ask some of my Drexel colleagues to chime in here as well. But there are a wide variety of student groups that are available. So there are groups that pertain to the professional societies, as I mentioned. There are completely social groups that you can get involved with, the Drexel Jedi, Dungeons and Dragons Club, things like this. There are groups that are affiliated with various technical aspects as well. So we have a Lunar Robotics Club that builds moonlander robots. We have the Drexel Cyber Dragons who participate in cybersecurity competitions, Concrete Canoe Club, Society for Automotive Engineers, that build cars and race them, like for alternative energy purposes. And so many different groups that are available. If there isn't one that matches your interest, and there's a tremendous number of them, you could certainly create your own group. I should also mention that for students who are coming from overseas, there is an International Graduate Student Association, and there is also an Indian student association as well, Pragathi, that's on campus. So, if you want to enjoy, social and cultural opportunities associated with this organization. So the students can certainly do that as well. So I don't know if any of my Drexel colleagues want to chime in as well with other student groups.
Yeah, thanks, Kapil. As Kapil mentioned, there's a lot of organizations at Drexel that really keep students interested, and a lot of them are fun. Some of them are professionally oriented. For example, my engineering management program, I mentioned about the American Society for Engineering Management. We have a student chapter organization that's associated with that chapter. So we're sanctioned by both Drexel as an organization, as well as American Society for Engineering Management. We also have INCOSE for our systems engineers. INCOSE is International Council on Systems Engineering. We have a student group in that as well. And again, it's a professional organization. What we do with the students, we tend to do things like we'll have a dinner meeting. It's non-formal, a very open. You dress any way you want, but we we have industry that comes in and gives various topics. Like one topic was on the autonomous vehicle. So a lot of different some topics are related to management, but students get the opportunity to attend this dinner session. We usually have one a term on campus, and it's free for the students. So you offer free food for students, you usually get them to attend. That's one way to encourage them, but also they're networking with local companies in the area that belong to these societies. And we also do some other things. We sometimes have tours to different facilities. So we engage the student from a professional perspective that also helps them with networking in their career. So that's another group of societies that we have for our students.
That's wonderful. Thank you, Rick. Thank you, Dr. Kapil. So one of the participants here has a question around, is there any particular course which would be relevant for CAD or CAM kind of background people who are coming from the computer-aided design background? Can they take up any particular master's? So that's
I can take some. My guess is this is not computer-aided design as it relates to chip design, but it's more on the mechanical engineering side, right? CAD. ME mechanical engineering, and we call it MEM here. They do offer a number of classes in the area. Now, I am off the top of my head do not know if there is a graduate class in this area, but I'm certain there are, a bunch of undergraduate classes in the area. But if you're interested, then I would recommend to check out some of the catalog information on the mechanical engineering side. Maybe there's what we call it's a MEM 500. So if you type in something like MEM 500 catalog Drexel, the entire catalog for MEM classes should pop up. And 500 is our what we call like introductory level graduate class. Now, just what I would note is that just because the course is on the catalog does not mean that the course is going to be. I mean, the catalog is usually much larger than the offerings every year, right? But a short answer is you will have to look at the mechanical engineering side of things for classes. But I would suspect yes, there are classes related to CAD and CAM.
So there are classes in that area. I guess I should emphasize that as part of this partnership, a Master of Science in Mechanical Engineering is not a pathway that we have as part of the agreement. There might be some opportunity to take classes along these lines as an elective, as part of the MS, and probably robotics and autonomy would be I think the closest program that would have that as a national elective.
So they do have an option to take a few electives from the other program as well.
That is correct. Yeah, but we have to, usually when the student comes here, we can sit and come up with a plan of study because there are prerequisites on the mechanical engineering side as well that need to be satisfied. So you may not be able to take the class without having taken few other prerequisite classes. So those things have to be addressed on a case-by-case basis. But yes, there are electives that the students can use to fill in classes from other College of Engineering departments, yes.
Yeah, so they can land with an open mind and then an entire pathway can be charted for them once they're on the campus.
Yes, that's correct. Yes.
All right, thank you so much. I think then we can take up a final question around how does an individual who is not from that much of a technical background, be it particularly software or computer sciences background, how can they switch into such a program? Can they go for something in engineering or should they go for something in business analytics or an amalgamation course like one that you presented on engineering management? How can they benefit out of it?
Well,
I'm sorry.
so that's a multifaceted question. Maybe let's kind of split that up a little bit. So, so there are two questions like that are there, I would say. So if you're coming from a computer or software background, there are programs at Drexel in computing and software that are not part of the Drexel engineering agreement with Futurense. We do offer a pathway to machine learning engineering, which, as Professor Kandasamy mentioned, has courses and foundations in ML foundations and implementation and engineering applications of machine learning engineering. We believe that's a real strength of our program, that we're not just looking at the coding aspects, but we look at the applications of the hardware implementation components. So if you have a computer science background, and are interested in getting a degree in engineering, this would be a good pathway to consider. You also mentioned, students who are coming with a computer science or software engineering background might be interested in engineering management, and that's also something that students can absolutely do. To complement, the computing side with the courses that we have in engineering management. We can certainly provide that content as well. So hopefully I interpreted the question properly. I don't know if Professors Kandasamy or Grandrino would like to chime in further, but that's how at least I understood the question.
Yeah, thank you,
Absolutely.
Kapil. The engineering management, it's a really good degree following, like a lot of our students, they majored in mechanical engineering, civil engineering, electrical, or computer, but they want to get learn the management skills on the engineering side. Plus, one of the things in our curriculum, our engineering management curriculum, is data analytics. We have a very strong data analytics program where you take 3 courses, which are engineering statistics, operations research, statistical data analysis, and then some even go on to take an elective, modeling and simulation. And the reason why we have these, because as a manager, and I remember this too, in my days as a manager at Lockheed Martin, you're often faced with ambiguous information and you have to make decisions. So if you can use data analytics to help quantify making that decision, it makes it that much more formidable. So we do have a strong, and that's one of the other things too that's different from our program with respect to an MBA. I encourage anyone that wants to stay in the technological field, especially working for technological organizations where research and development is oriented and applied. Take an engineering management degree. That'll give you a much more better foundation to manage both capital and human resources. And again, we teach leadership skills. So it's very applied oriented. Students work in case studies, and because management is just a gut feel. You could read from textbooks and learn about the foundations of management, the principles of management, but we teach beyond that. We teach leadership skills. And we even tell our students too that, the leadership skills, we get feedback that it resonates in their organization. They may be an entry-level engineer and then all of a sudden be asked to manage like a small project team because their leadership skills are standing out. So I hope that answers your question, probably more lengthy than what you were looking for, but it is a good degree following the degree that you have, the STEM degree in math, physics, engineering. This is a very good degree that adds to your capabilities. Did I answer your question?
Absolutely. Yeah, perfectly, actually. That gave a lot of insights into what kind of program our candidates can expect out of engineering management. Thank you. I guess with that, we can wind up over here. We're slightly shooting over the time. Thank you for your patience, everyone, Dr. Kapil, Rick, and other participants, Naga, Tupi, and others as well. Thank you so much.
I hope this was helpful, guys. I tried my very best to ask all the questions I thought were relevant to you. But if you still have doubts, if you still think you are very interested in building a career in the US, pursuing your master's from a top US university, have more doubts, definitely reach out to us. Definitely book a one-on-one counseling, free counseling with our counselors, our in-house experts, to try and understand what are your chances, what are your prospects of doing the master's from a top US university using the Futurense US pathway and build a high earning career in the US. See you.